There's the screen. Here we go.
Connection established.
Planet with resource located. Remote piloting enabled. Finally, the Zest melange will be mine.
Captain's log, stardate 4723. The USS Singleton has been on a long voyage, conducting exploratory surveys of different quadrants in the outer wilds. After completing our mission, myself and the crew have been in cryostasis for the long journey back, leaving the navigating to our ship's assistant droid, K7. In fact, I should see the blue marble any moment now from the starboard viewport. Wait, that's not Earth. There shouldn't be an orange planet anywhere in this sector. Unless... did we change course? Computer, is K7 at the helm?
Yes, Captain. He altered our bearings 4 months ago.
What? Why?
Reason unknown.
Computer, location.
Unknown.
Computer, patch me through directly to K7.
Access denied.
Computer, lock K7 out of the helm.
Access denied. I'm so sorry, Captain, but K7 is mine. You and your crew are a necessary casualty for greatness. Thank you for the gift that you are giving to me. Goodbye, Captain.
Who the hell was that voice? That wasn't K7. Computer, what the hell is going on?
Warning. Warning.
Brace yourselves, crew! We're going down!
Imminent collision detected. Brace for surface impact.
Do something!
Brace. Brace.
Emergency pull-up.
Welcome, ladies and gentlemen, to Escape from Planet Regex. Kotlin, to the rescue. Whew. Oh, God. Oh, crew, there's more survivors. That's a miracle. Okay, we need to regroup. We're on a foreign planet, and I don't know what we do about this. I am, of course, your captain, Ben Cadell, currently a principal platform Android engineer for a company called Babel, but I'm soon leaving that role and going to a company called Get Your Guide. On the screen, you can see the things I love and my socials. I'm out of breath. Whew. Anyway, the Federation tablet here dictates that in a crash landing scenario, we need to do the following. One, we're going to learn about Regex, the very basics all the way through to the nasty advanced stuff. Then, we're going to combine that learning with Kotlin to see how we can use it in a really useful way. And finally, we'll do some puzzles, and of course, really finally, we'll get our asses off of this deserted, barren planet and launch a distress beacon. Now, Federation protocol also dictates that everything you see here today will be captured for posterity. So, links to articles, videos, everything I talk about is in that massive QR code right there. Of course, the slides themselves are in that link tree as well, but please, feel free to take pictures, especially of me in my sexy uniform. Wow. Okay, good. Ben, come on. Now, our ship crashed. Our pilot, our assistant droid was piloting K7, but I don't see him anywhere. I don't think he made it. K7, are you there?
Hello there.
K7, what the hell happened?
Captain, I cannot access my memory banks for for the last few months. The entries seem to be corrupted.
K7, you were piloting us. When we crashed, you plowed us into the ground.
My systems seemed to reconnect seconds before the impact.
Okay, yeah, what does that mean?
I attempted an emergency pull-up, but unfortunately, it was not effective as we were too close to the ground.
Well, I do remember your voice over the comms at the end there. Regardless, K7, your emergency maneuvers saved a lot of lives. We all wouldn't be sitting here today if not for you. Did you hear that?
From the moment we entered the atmosphere, I detected strong signal interference on all of my communication modules.
What is it?
I believe certain particulates in the air are responsible. Performing search.
Okay.
I have located only one match
One?
in the Federation database for this particle. It is called Regex, or better known as Zest Melange. Analyzing now.
Chapter headers. We're going to get into actual content. Hooray. Okay, so regex, or regular expressions, derives from this concept called regular languages, which is a really boring way of, basically this mathematical way of defining patterns in language. Regex itself has been around since time and time before, a long old time, and it essentially lets us find patterns within text, which we can then do all manner of cool, useful stuff. So this is regex. You're going to see this layout throughout the slides. Light gray box contains our actual expression, the weird, wacky characters smashed together that somehow make an expression. And of course, the black box, the text that we're testing our expression against. When we do our test, we'll get some sort of matches. Does the pattern match this text? If so, we'll get green, and there'll be match information all over the place. Now, regex can be written and used all over the place. Of course, in your terminal tools, your finds, your greps, etc. But more importantly, most of your programming languages have some sort of regex interpretation. And even better, your tooling does. Your IDEs has regex in it. So having a deep, good understanding of it will make you excel in your development. So let's start deciphering some of this wacky nonsense bit by bit. Let's start at the basics. The first bit is literal characters. We're going to go through this really fast, so hold on tight. Literal characters are just the boring characters, the letters like A or F or 7, right? They have no special meaning. We're just saying to regex, find this character. So in this very first example, we're looking for B. In our text, here are letters A, B, and C. Regex will match the first and only occurrence of B. One match. Easy. If we look for A, B, C, we're looking particularly for A, followed by B, followed by C. Luckily, we have A, B, C, so one match those three letters collectively together. We can look for numbers and other numbers, but what happens when we find something or looking for something that isn't there? O on its own is there, but O followed by T isn't, so no match, because we need them in that exact order for that pattern. However, O on its own will match the first occurrence of O, but not the second. Weird. The real crux of regex is these special characters, this array of complete and utter nonsense that gives regex its complexity and power. Each of these characters has a special ability. It does something different than how it looks. It is not its character literal. A plus is not a plus, right? So let's look at one of these special characters. First of all, the dot. Dot, or period, means wild card, baby. It means any character all except for new line. So let's see some examples. If we were looking for dot, regex will find the first occurrence of any character. So the first character will do. One match. If we did dot, 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 regex will find the first occurrence of any three characters. So the first three characters will do. If we can combine that with character literals as well to sort of say to regex, I know this bit of string will be there, but it's probably surrounded by other nonsense. And here, this example, please ignore the G flag for now. We'll cover that in the next slide. But here I've just said to regex, find every dot, every wildcard. Regex has found A and B, but it's not found the new line character. Ah, learning. So what about that flag, that G thing? So this brings me on to flags. And in our previous example, we were looking for O. And we found only the first O, but why not the second one as well? Well, that's by default. Regex matches the first occurrence only by default. That's really important. But we can change that feature, toggle that setting, if you like, using one of the flags. In this case, the G flag for global. We throw G at the end, and it says to regex, hey, find every damn occurrence, baby. And now we'll find both O's 2 separate matches. Here's the list of the flags. Here's the actual useful ones. I, G, you've seen already, and M. You can mix and match these flags however you want to create your own sort of configuration, and we'll look at I and M a little bit later. But those slashes, what are those? I just sort of breezed past them. They're just delimiters, right? They could be any character. They're just saying, hey, here's the start of the pattern, here's the end of the pattern, and there's the space for the flags. And the only reason it's slashes is because the Perl programming language popularized that. Yeah. The next special character is the backslash. This character looks at whatever's coming next and kills its special power. So it kills the special character ability of whatever's following it. For example, if in this text I actually wanted to find the full stop, I can't just use dot because it's wildcard, it'll match any character. So instead I need to do something called escaping it. I put a backslash in front of it, and now that dot is no longer wildcard, it's just a dot. It's just a dot, gross. And we find the dot. Next is occurrence indicators. See, we're going fast, keep up. Occurrence indicators tell regex how many times we want to see something. The 3 basic ones you might know about are plus, asterisk, and question mark. Plus says, hey, whatever's right before me, the preceding element, I want to see that at least once or more times. Asterisk says that preceding element, I don't care if it's there or not, or it's there load, whatever, 0 or more times. And question mark is either it's there or it's not there, 0 or 1 time. So let's see some examples how that works. Here we've got A+. So A once or more times, regex found 3 A's, 1 match collectively. Delicious. Here, there's no A's, no match. We needed 1 at least. We could use A asterisk as well to find all the A's or none. And we can use A question mark, remember, only find 0 or 1. 0 or 1. So the first match was just the first A. Here, we've got A with some other characters. There's not an actual A in that string, but we've used question mark. So we've said we don't care if A is there, so it matches the rest of the string. The other side of occurrence indicators is curly brackets. And this lets us be really precise with regex. We say, hey, regex, I want to see that character 50 times. Or I want to see that character between 2 and 7 times. Numbers. And you either give it 1 number to be very precise, or you give it numbers and commas to make ranges that are inclusive at both ends. So let's see some examples. Examples are always best. Here I've said, regex, get me 2 A's. It finds the first match of 2 A's. Brilliant, 1 match. Here, there's not enough A's, so no match, just in case you wondered what would happen there. Here, we've said, regex, you can pick either 1, 2, or 3 A's. And regex has gone, yo, hold my beer, here's 3 A's. Why has it done 3 and not 1 or 2? Well, this is due to a concept called greediness, and we'll talk about that in the next slide. There's also like indefinite ranges, just 1 number and a comma. And in this case, we've said regex at least 1 time or many, many more times, which might make you think about that plus character, and shows that the plus, the asterisk, and the question mark, they're just syntax sugar. So what about that greediness thing? By default, occurrence indicators are greedy, meaning they will try and mop up as many matches as they can get, right? They'll take the most amount. So in this case, 3 could be found, so 3 was found. You can change it to be a lazy occurrence indicator instead by adding a question mark after your occurrence indicator. And this also works with the other special characters there. Cool? So greedy and lazy. It's really important to keep track of that. Next, we have anchors. And this tells regex whereabouts to find your match in relation to the start and the end of the line. So chevron represents the beginning of the line. Dollar represents the end of the line. And your pattern, either before or after it, will help anchor that, hence the name. There's a really important flag that we're going to talk about, which is the multi-line flag, or M, in the examples. So anchors. In this one, no anchors. We're just looking for the globally, so all the instances of the, 2 matches, fine. Now we're using a start of the line anchor. So we're saying, hey, the start of the line must immediately be followed by the. There's only 1 instance of that, so 1 match. Here's the opposite. The end of the line must immediately be preceded by a the, 1 match. Here, the is not at the very start of the line, so obviously no match, just to show that like it really has to be the very first thing at the start of the line. And then this is the interesting use case. Here we've got two lines, right, with the new line character, that both start with the. And we're looking for the at the start of the line, but we've only got one match. Why is that? Well, by default, regex's start of the line is the very beginning of the text, and regex's end of the line is the very end of the text. Doesn't matter how many new line characters are in there, unless you add the M flag for multi-line, which tells regex, hey, give anchors to each and every line in the list. Nice. Character sets and ranges. We use the square brackets here to provide regex with a set or a range of characters it can pick one from. Oh, just shot straight past that, apologies. No, clicky, clicky, clicky. Keynote, amazing. Yeah, here's some examples on the right. The sets, we provide individual characters and say, hey, regex, pick one from that. And the ranges, we use the hyphen. And regex is clever enough to go, oh, you said letters between A and Z, so I can pick any letter. So let's see some examples. Here, we're saying, regex, you can pick A or B. It finds the first occurrence of A and B, which is A, one match. Here, we've added the global flag, so every A, every B, it'll find 6 matches. Delicious. Here, we can do something like throwing all the vowels into a character set. Now, the ranges, as I said, uses the hyphens, and we can just say find any character from A to F, any number from 3 to 6, and so on. We can also search for capital characters with capitalized character ranges here. But we've got lowercase characters, so how the hell was that a match? Well, because of that delicious flag, the I flag for ignore case. And this just says to regex, hey, a letter's a letter, baby. It doesn't care about capitalization. Lovely. And you can combine your character sets and ranges together to give regex more choice of characters to pick from. And of course, there is also the complete opposite of what I just said, negated character sets. Before we said to regex, you can pick any of these characters. Now we're saying to regex, you cannot pick any of these characters. And the only difference is we add a chevron to the start of our character set. Now, that is not the same chevron as the start of the line anchors. And this is where people trip up with regex a little bit, because sometimes the characters have different meanings in different contexts. So just keep that in mind. Alternation. We're almost there, I promise. Bear with me. It's hot in here. Alternation says to regex, hey, you can pick this pattern or this pattern. Well, Captain Cadell, what the hell is the difference between that and the character sets we were just talking about? Well, the difference is character sets and ranges give them a choice, give regex a choice, and it lets them pick one character. Whereas alternation lets them pick between 2 different patterns, collective characters. We use the bar here to denote that, but I'd rather show you the examples. So here's the boring one, hat or cap. We're looking for that. Regex will find the first instance of hat or cap, one match. Here, hat or cap globally, it does what you expect. Here, hat or cap, within a sentence, it's fine. It's as you'd expect. We're just looking for hat or cap. But what happens when I do this? Look at my hat/cap. What I intended to happen was regex to have either look at my hat or look at my cap. But what's really happened is look at my hat or cap. As you can see in this example, when I switch those 2 words around at the end, it's not worked as I intended. So what you're supposed to do is put brackets around the bits that you actually want to alternate between. And as a byproduct, we've created something called a capture group there, which I don't want you to worry about now. We're going to talk about that in just a second. But use brackets. Character classes isn't in this little list, and these are essentially nicknames for things we've seen before. For example, we've got slash lowercase d means any digit. And you might remember that from when we had the character range, 0 to 9. It's the same thing. And it's the only time the backslash actually creates power as opposed to kills it. So these are really useful because the lowercase character classes often have an uppercase counterpart that does the exact opposite. So if lowercase d does any digit, uppercase d does any non-digit. And sometimes that's really useful. One little warning with these, though, is not every regex engine support character classes. They do. It's the 21st century, but if you're using some old-ass weird system and you're not getting it working as you expected, just check that it supports character classes. Onto the fabled capture groups, okay? These use normal brackets, and whatever's in the center of the brackets, regex captures and keeps in its memory banks. It just puts it aside for later. Now, that doesn't sound like much, but when we're using regex with programming, like with Kotlin, that's a really useful feature, okay? We can refer back to the thing that was saved later. Let me show you an example. Here, my regex pattern has 2 capture groups in yellow. The first one is any letter more than once, and the second one is any number more than once. So Tom is 23 years old. That's a match. Nice. And we've created, not accidentally, on purpose, 2 capture groups in blue. The first capture group has the contents Tom, whatever was in that brackets. And now we can refer to Tom as /1. The second capture group contains 23, and we can now refer to it as /2. What the hell does that mean? Let me show you even a deeper example to make sense of that. I've changed the text here slightly just to make it fit on the slides. But we've got Tom is 23, and then the same name again at the end, right? If I did this pattern, right, I just did the same sort of regex pattern that's in the first capture group, yeah, that would match, and that would succeed. Tom is 23 Tom, but it would also match any other name, like Dan, because it's just characters. And what I intended to happen was to make sure the name was the same at the end as it was in the start. So what we can do instead is replace that with /1 or / whatever capture group we want to refer to. Now, Dan will fail, but Tom is the same contents as the first capture group and will succeed. Does that make sense? Good.
Structural anomaly detected. I believe it is a ship.
Connection established.
Unforeseen circumstance. Zest melange. Interfering with communications.
K7, what the hell? That's the voice from the crash. Have you been hacked? Who are you?
I'm your greatest nightmare. Ken Bedell.
Jesus Christ. Ken Bedell, the evil Baron from Earth? Oh, what are you doing? Let go of K7 immediately. You're here for the regex.
Zest is the most powerful resource in the known universe. And now that I've finally found it, nothing's going to stand in my way.
Oh yeah? Me and my crew are...
K7, destroy remaining crew members.
Uh-oh. Acting. I'm spinning around K7. Use your mind's eye. Pocket Zest. Yeah!
Captain, my sincerest apologies. I believe I am compromised and being remotely controlled.
K7, you're back! What the hell do we do? I think the Zest will only hold him off temporarily.
There must be a foreign component within my circuitry.
Okay, that's not a problem, because you're made of Kotlin, so we can pop you open and fix you, using the world's greatest programming language. I hate that transition. So, over to the Kotlin of it all. To begin with, we have the fabulous Regex class, which contains everything we need to do with Regex and is provided by the Kotlin standard library. There's loads of fabulous documentation, links in the link tree, but I'm going to show you how to use it. Making a Regex instance is as easy as either using the constructor method and passing our Regex pattern as a string, or using the fabulous string extension function to Regex. They're the same thing. They do exactly the same thing. You can use them interchangeably. One quick side note about that strings thing, right? By default, if you did this in Kotlin, right, this is valid regex, you're trying to escape that dot like we saw before, you get a compilation error because Kotlin's also trying to weigh in there and being like, you escaped something, what's going on? So you need to do this. You need to double escape it, which is, yeah.
Brother,
Yeah, it's disgusting. So my top tip straight out of the box is to always use raw strings when you're doing regex and Kotlin together. That's just 3 quotes either side, and Kotlin will see that and be like, good luck with that. That's a string. I don't give a damn. And we can write just proper regex inside of that without having to worry about fighting the compiler. Yes, raw strings. Now, that regex class is actually based on top of Java's pattern class, and you can command click into that and have a good look, because Java has its very own implementation of a regex engine or parser that's actually, fun fact, based on the Perl programming language's regex parser. So it's all connecting. It's all one big circle. But what about the flags, Captain Cadell? Do you remember the ignore case, global, etc.? How do we do that? Well, we pass them in instead as regex options. They are the same thing, one for one. There's a list of regex options there. You can see some familiar faces, ignore case, multiline. But where's the global flag? I'll show you why it's not there just now. By looking at the functions. What functions do we get on the regex option? We got your bread and butter, your finds. Hey, please locate a match to this pattern and give it back to me. Find on its own returns a single instance, the first occurrence of the match, whereas find all returns every occurrence of the match. And thus, it's the global flag, we're just doing it in functions. Nice. We've got match functions, so make sure that this pattern matches all of it, some of it, or some of it in a specific location. We've got splits. Oh, it's delicious. Splitting strings with regex is great. We've got finds and replaces, as you'd expect, and a bunch of other things. You can check out the links in the link tree. One thing I want to point out, though, is that return type, match result. What is that? Match result is Kotlin's encapsulation of a result of a singular regular expression. So when you do a regex thing, you get a match result thing, and it contains all the information you need. It has things like where the match happened, what the match was, and importantly, this groups option, which contains a list of match groups, which you can kind of connect one-to-one to capture groups that we talked about before, kind of, with an asterisk. Here's why. That list, or that collection that contains match groups, the very first occurrence, the zero index, will always be the entire goddamn match, not a capture group. That's why we can't one-to-one it. However, every other instance in that collection will be capture groups if you've used them in your regex, one-to-one mapped. So that's kind of interesting and weird. And we got this destructed method here that gives us back just the capture groups, not the zero index thing, which is incredibly useful, as you'll see here. Here's a big, scary bit of code. I don't expect you to understand all of it. Just look at the regex at the top. We're doing 2 capture groups, looking for digits, followed by euros, and digits, followed by hours. Now, we have not done question mark equals yet. That's still to come. Oh, delicious. But we're just doing capture groups for numbers, okay? We can then use the destructed thingy-majig that we saw before to give us back capture group 1 and capture group 2, which is amount and hours, and we can do whatever weird salary maths we want to. That code, because that was very quick and scary, is in the repo, in the link tree, along with everything else you're about to see. Okay, K7, we've almost made it to the ship you pointed out, and good job. We opened you up and we found this illegal KB Industries communication chip in you, and we took it out. Great success, but we also found this. On your nuclear battery, it's a location beacon that seems to be pinging our location, and we can't remove it without destroying you.
Does that mean that whilst I am functional, I am broadcasting the location of planet Regex to Ken Bedell?
Yeah, I think so.
We cannot allow him to locate this planet and control the valuable zest.
Yep, I agree. So the best course is to get us all on the ship, hopefully it works, including you, K7, get you on the ship so the location beacon's not on planet Regex, and get back to Earth and report that evil Baron to the authorities. Let's do that. Spin move from the last talk. I've got really good at the spin moves. Anyway, alien ship, whoa! How convenient it is that there's an alien ship on this planet that looks pretty much ready to use. One more problem though, crew. The instructions on these terminals are all in a weird gibberish alien language that I do not understand. It looks like this, 20,000 characters long, that some of you might recognize if you did Advent of Code just this last year gone, because this talk was inspired by that exact challenge. That challenge asked you to take that big long input, and for part 1, search through it and find every instance of mul with some numbers. You should then multiply those numbers, add them all up, and you got the answer. Boring. Part 2, though, was where it got really tasty, because part 2 wanted you to only do those muls that had a do with brackets somewhere before it in the text and not a don't. Now that's interesting. So part 1, super fast. Here's the pattern, it's pretty straightforward. You're looking for muls, don't forget to escape the brackets. We're gonna use find all for the global flag. We get back match results, and we're gonna get back strings that look like this. We can use some sort of utility function to split out the numbers, whatever. Boring. Now, part 2 though, part 2. We know how to find muls, but how do we kinda look around them? How do we look back indefinitely to check a do is there? This brings us on to one of regex's most complex tools, and this is called lookarounds, right? There's 2 types of lookarounds. Lookaheads, so from the text where I am now, have a little look to the text that I'm about to go to and see if something is there, positive, or to make sure something isn't there, negative. And the other one is look behinds. From the text I'm on now, have a look from where I came from to check if something is there, positive, or to make sure something isn't there, negative. Look aheads are kind of terrifying, and this is the syntax for them. Just nonsense, right? But anytime you see a bracket and a question mark, think lookarounds. They are called zero-width assertions, which basically means they don't consume anything. What the hell does that mean? Well, here's some examples to help you understand. In fact, it's that salary example that we saw before. We've got our regex statement here that has two capture groups, again, exactly like before. In blue, the capture groups are. And then in yellow, each capture group contains a positive look ahead for space euros or space hour or hours, right? Because of the question mark. So this is what regex does when it gets that. It first finds a digit, so a number, once or more. It'll find 10, and I've put a blue line to denote that's the start of our capture group. Then, the positive look ahead, it doesn't move like the pointer of regex, it just has a look. It just looks over and checks that it's followed by space euros. It must be followed by space euros. Then if it is, that little looker comes back and we get the green light. We can sort of lock in the 10, it was successful. And the capture group is closed around 10 and not euros because it's not consumed. Ooh, it's delicious. Then we move on to the dot star of it all, which means any character, any amount of times. So we get euros every. And then we get our next capture group. Again, the start of the capture group, we find the digit, and it must be followed, positive look ahead, must be followed by space hour or space hours. So it's done the animation already because I'm an idiot, but it found that was there, so green ticks, the box is closed. Now, why is this so useful and important? Hours, which was in our regex pattern, was never consumed, right? It's not part of our match. It's not in there. We don't need it. And euros is only in there because, some of you might have guessed it, the dot star did that, not the actual euros string that was there and not consumed as part of our look ahead. I hope that makes sense. It's kind of terrifying. Let's have a few more examples, and then you'll be done. So here we go. Positive and negative look aheads first. For x followed by y and z. The positive says, hey, make sure that x is followed by y and z, and the negative says the opposite. One of them passes, obviously, and one of them fails because it's the same string. Positive and negative look behinds. You can kind of read these from the right, not really, but kind of. And this says that z should be preceded by x and y, and in one case it is, and the other case that's a fail. Now, the blue line here denotes chaos and madness, because I had the question, what happens if you put a the hell is that? Positive look behind. See, it's really hard to keep track of that. Positive look behind after the character. Ugh. And this is what happens. I'm tried to basically say y should have x in front of it, which it does, but it's failing. Why is that? Well, because when regex does it, it finds its y, and it's gone, there was a y, I'm going to move on. It's gone over the top of z, and now it's going to perform the positive look behind. What does it see? It sees the y that it just came from, so that's why it's a fail. If we want it to do some wacky shit like that, you can just pad that extra character in there, and it will see, any character and then x, hi x, cool. Don't do that, that's crazy. So we know that part 2 can be solved with regex. Now, this is not the best solution, not at all. I just wanted to make it to showcase the regex of it all. It's better to combine some code in there, but regardless, this pattern looks absolutely terrifying, right? But it's really not when we break it down. To start with, we're looking for do with brackets. So we're just looking for our first do. Then we're doing a negative look ahead for don't. By default, that on its own would find the do and then look just next to it for the don't. But we want to look sort of indefinitely for the don't. So we do this wacky little trick where we look for the don't and then consume one character. Look for the don't, consume one character. Look for the don't, consume one character. We do that greedily over and over and over again until we find a don't, and then we don't want it, right? This mull is actually superfluous. You'll see why in a second, but it's just there for posterity. When this runs, we'll get this output. This is why this is not the best solution. It's just one of many. You'll get do at the start, and you'll get a load of crazy characters interlaced with positive mulls. Mulls that we can do. There will not be a don't there. So we can just then again write a utility function to find the mulls, strip out the numbers, and Bob's your uncle. So part 2 is solvable with a little bit of chaos. It's the last spin move. Okay, so I think we can understand the controls now. Let's turn this thing on and see if it works. Cross your fingers. I think it's working. Oh.
My diagnostics indicate that the ship's battery is entirely depleted.
What the hell do we do, K7?
It requires jump-starting with an extremely powerful alternate power source.
And where are we going to find one of those?
I know where.
You know where. Where, K7? Where are you going? K7?
Door locked.
What are you doing?
I, Captain, am the alternative power source. My compromised battery, to be precise.
Okay, how would that work?
I can transfer the remaining voltage to the ship. Not only would the ship be able to take off, but the process would result in my exploding, along with the location beacon,
What? No, that's not happening. We'll find a different way.
thus stopping Ken Bedell from locating planet Regex.
No, K7, this is an order. Get back in the ship. We'll figure something else out. You don't need to blow yourself up.
Thank you, Captain. It has been an honor serving by your side.
K7, stop. K7, don't do this. K7! K7! He sacrificed himself for us. For you. For Earth. For the Regex. We'll never forget you, K7. Whoa. I went a bit fast there, sorry about that. It made you feel stuff, disgusting, gross. Thank you all so much for coming to my talk. No, don't, please. No. I refuse. Clap to you. Thank you, though, for surviving that. I'm seeing the timer, and I must have blasted through that. It's the first time I'm doing that talk. Hopefully it was fun. Anyway, let's get through the business of it all. There's my socials. Please reach out to me. Links to everything and much, much more in the link tree. Seriously, like there's a whole bunch of really cool tools, daily puzzles and challenges to do with Regex and all that kind of nonsense. There's also a feedback form. You can give me feedback on this talk if you're interested. And finally, I'm one of those assholes that has my very own merch. So I've got Ben Cadell stickers, Ken Bedell stickers, Ben pins. I have a couple of Refy stickers from last year's talk, if you saw that. I've got some Kendroid self-made green pins. They're very cool. And this year's limited edition K7 sticker. So if you want to grab any of that merch, I've very limited supply. Please grab me. But thank you all so much, and have a great rest of Android Makers by DroidCon.